Well, it might be a little hard to fit all this on this little board of mine, but here we go. Given this graph of y equals 1 over x, and here it goes. Graph y equals to -2, parentheses, 1 over x minus 2, and then plus 1. All right, this is a little background on this problem. This graph, this shape, is known as a hyperbola. And hyperbola is can be a naturally occurring shape, and actually, if you were to actually see the shape of the sound striking the ground when a jet airplane creates a sonic boom, you know, when it passes a sound barrier, it creates a very powerful packet of sound, which we hear as a big boom. And these things can be powerful enough to actually break windows. So, yeah, and living kind of close to Wright-Patterson Air Force Base as we do, it's I'm surprised we don't hear more of those sonic booms. Okay, well, in any event, the cone of sound that emanates from the plane as it strikes the ground actually forms this shape. All right, now I can't think of a practical application for it, but there's a natural occurrence of it. And there's a lot of other places where you can find hyperbolas. For example, when we when we sent those guys to the moon back in the late 60s and early 70s, when they left Earth orbit to go to the moon, they were traveling upon a path that was hyperbolic. So, oh well. Enough about that for now. You would study hyperbolas in our trigonometry course, if you take that. Now these green dashed lines is part of this graph, and it's a part called the asymptote. And it means that the graph levels off toward those. So I think I may have spoken about asymptotes in an earlier video in another chapter. I'm kind of drawing a blank now, but what it means in this context is that the graph never crosses these asymptote lines. Well, they become a feature of the graph that we can exploit, because what is the center of the asymptotes? Lo and behold, it's the origin. So when we think about horizontal and vertical translations or shifts, that's going to shift the asymptotes. So that's going to come in handy in graphing this. Anyway, all right, well, let's see what we can do with this. First, I think we should identify the transformations. And again, the more you write down in front of your face, I think the easier it's going to be. So let's see, there was a reflection. So we have a reflection across the x-axis. And was there a stretch? Yes. 1 over x, that function looks like it was multiplied by a 2. So it was a vertical stretch by a factor of 2. A factor of 2. Alright. And then the horizontal shift, x was replaced with x minus 2. That means it went 2 units to the right, positive. So we have a positive horizontal shift of 2 units, and then a positive vertical shift. The plus 1 is, again, this is separate from everything else. So plus 1 means that would be the vertical shift upward by positive 1. All right, now I don't have room to keep all this on the board and draw a new graph, obviously. So I'm going to violate my no sloppiness rule that I would expect from you. I would expect you to draw a separate graph. And but I think in order to talk about this intelligently, and so that everybody can understand it, hopefully, but put it all on the board, I'm going to need to keep this graph up here as well as these transformations. So I think what I'll do is I'll draw the new graph with different colors. And it's going to be cluttered, but just to give you the idea here. So don't do this yourself. All right, I would expect a clean graph. All right, now it's reflected across the x-axis. That means it's going to be going in that direction, roughly. So it gets flipped around. So this comes down to the fourth quadrant, and the third quadrant goes up to second quadrant. Vertical stretch by a factor of 2 is going to distort this, and we'll deal with that in a minute. But the horizontal and vertical translations or shifts, right 2 units and up by 1. So let me, I'll do that in red. The right by 2 units means the vertical asymptote gets shifted by 2 units, and the horizontal asymptote goes up by 1 unit. So there's the right 2 up 1, because you think of it as going from this center to here over 2 up 1. Alright, so there's there are my new asymptotes, and it's going to kind of look like this and like this. Alright, let's see here, when I start at the center, and if I go right 1 unit, I go up 1 unit. Oops. Telephone. Be right back. Okay, I'm back. Now if I just figure out where I was, let's see. We took the center of the asymptotes, which was a landmark point, and since it's at the origin, it's especially valuable, and we shifted it right 2 and up 1. All right, and this goes down here. All right, now I remember. When to get to this point, I have to start at the origin or the center of the graph and go right 1 and up 1. Here, I'm going to go right 1 unit, but down 2 units. So that means this point is now over here. All right, so I hope you can see that okay. Start at the origin, right 1, up 1 gives me this point of the original graph. Here, start at the origin, go right 1, down 2 instead of down 1. Down 2 because of the vertical stretch, and down because of the reflection. So this point shifted to there. If I went right 2 units, I go up 1/2. Here, if I go right 2 units, I'm going to come down 1 instead of 1/2, twice as much. And then here it's going to be right 1/2 up 2 would be right 1/2 down 4. So let's see. Where would that be? Right 1/2 up 2. From here I go right 1/2 and down 4. Takes me down to -3, right around here. Alright, so that's sort of, I hope you can tell that stretched that out. This is probably not the greatest example for demonstrating stretches, but it does distort the y direction. It has been pulled by a factor of 2. So I'm going to do that over here. Let's see, left 1 up 2 units, left 1/2 up 4 units, left 2 up 1 unit. So it comes out like this. Alright, so that's the idea. Alright, a little cluttered. Sorry about that. It's just pretty hard to fit everything of this problem onto one board at one time. But again, I encourage you to read my book, and I use all the necessary space in there to space things out. All right, so that's our another type of problem that I want you to be able to learn. And I got one left, and it's probably the easiest of the three. Once you learn your transformations.